Hi guys, so we are skipping over 2.3 for this one. Any of those topics are going to kind of come up later within this chapter, so not something we need to talk about yet. So we're moving on to 2.4. 2.4 is all things factoring to find solutions. Okay, so at the end of solutions to equations using the different methods of factoring that we know. So the three things that I need to kind of teach you for factoring today is factoring out a monomial, difference of cubes, and sum of cubes. So we'll have two more days on 2.4. So this is technically just going to be our part 1 to 2.4. So to begin with, the first one we're going to do is factoring out the common monomial. This is also referred to as the greatest common factor within the expression. So when we talk about the greatest common factor, we have to look at each one of these terms and see what's something that we could factor out of each of them evenly. So it can't be like, well, I can take x to the third out of this one, x squared out of this one, and just x out of this one. We need to know what's the same equal term or monomial that we can factor out of each one of these. So with it being a coefficient of 1 in our very first term, that means that we won't be able to factor out any actual numbers, but variables we will be able to. So since each of these terms has an x, we can factor out an x. We always have to take, again, the smallest amount of the variable or the number that we have, because I can't take x cubed out of x, but I can take x out of x cubed. So when I factor by something or factor something out, I put it on the outside of these parentheses. It's the same thing as dividing each term by what I factored out, because now I need to figure out, well, after I factor out an x, what's left in the rest of my expression? So we can take x cubed divided by x. That gives me x squared. Then we have 2x squared divided by x. That leaves me with 2x. And negative 15x divided by x, well, that just leaves me with negative 15. So the thing about this, though, is after I've factored out that common monomial, I'm not done. I have to see, am I as factored as I can get? The answer here will be no, because looking at this expression, think back to chapter 1. If we were faced with a trinomial, since there's 3 terms, how would we go about factoring that? We would find 2 terms that multiply to be our last term and add to be our second. So we know we have to put an x way out here and then set up 2 more binomials with x's in the front of each of those. So let's start thinking about factors of 15. We have 1 and 15, 3 and 5. That's about it. So what could we do with these? How can either of these multiply to negative 15 but also add to positive 2? So clearly 1 and 15 is going to be out. That's not going to happen. There's no way I'll add to positive 2. But when we look at 3 and 5, if I make 3 negative, negative 3 times 5, negative 15. Negative 3 plus 5 is positive 2. So in any order, I can put both of these numbers into my binomials. So one extra step here, and we did it on a couple of them within chapter 1, but when we want to solve or find solutions to the equation, everything needs to be set equal to 0. So I'm going to take this first term, second binomial, third binomial, and set x equal to 0, x minus 3 equal to 0, and x plus 5 equal to 0. We need to solve each of these for x in order to find our solutions. So this one would be x equals positive 3. This would be x equals negative 5. X is already solved for in this one. So if I set up all my solutions, it would be 0 coming from this top one, 3, and negative 5. That would be factoring to find, so this is the next example. This would be factoring to find my solutions. Okay, so that's it for that one. So let me draw a little line so you know what that problem was. So now I have a second example for you of factoring out the greatest common factor or the common binomial. So first, let's look at the actual constants or coefficients here. We have a 2 and 18. Between 2 and 18, they both have the common factor of 2. So I can factor out 2. Now let's look at variables. I have y to the 5th and y cubed. I have to take the least amount that I have, so that's going to be y cubed. And now I open this up to figure out what do I have left over. Again, factoring something out is like dividing each of those terms by what you factored out. So I'm factoring a 2y cubed out of each of these terms. What we learned from exponent properties was obviously these 2's cancel. We knew that before. But when we're dividing and at the same base, we subtract their exponents. So I'm going to have y squared left over here. Now, 18 divided by 2, negative 9, right? It's negative 18. And y cubed, cancel. So I'm left with 2y cubed multiplied by the quantity of y squared minus 9. Now, what does this part look like? Can we do anything more with this binomial? Hopefully, you're starting to see that this looks like difference of squares method of factoring. So what we have to find is what my a value is and what my b value is, because we'll take a plus b times a minus b for difference of squares. We already have our a, that's y. Now we need to know what the square root of 9 is. The square root of 9 is 3, so it's going to be plus, oh, I said b, sorry, plus 3 and minus 3. So when we take this down one more step, right, just combine this with what we found it to factor to. We have 2y cubed times y plus 3, y minus 3. This is as factored as it can get. So at this point would be, again, when we go to actually find our solution. So we would take 2y cubed equals 0, y plus 3 equals 0, and y minus 3 equals 0. Both of these are obviously just adding and subtracting. With this one, let's pull this one over here. First thing we'd want to do would be divide by 2. So y cubed equals 0, because 0 divided by 2 is still 0. And then we want to cube root both sides. Again, cube root of anything like that is 0, so we'll just have, again, y equals 0. So all the solutions would be 0, negative 3, and positive 3. Again, factoring as much as we possibly can to get to these solutions. So that, both of those two examples go for factoring out the greatest common factor or factoring a monomial. So let's get this set up. Oopsie. Okay, so the next thing we need to talk about is this top here, sum of cubes. So sum of cubes kind of is a spin-off of the difference of squares that we did in chapter 1. What you want to do is find what your a value is, so something that's cubed, and your b value, so something that's cubed. And then you can apply this formula of a plus b times a squared minus a times b plus b squared. Okay, as soon as we figure out what our a and b are, we just throw them into that equation. So looking at this first one, we already have x cubed. So obviously our a is going to be x. But then we need to figure out what number cubed equals 64. So another great way to go about this is by taking the cube root of 64. So the cube root, or something that's, or the cube root of a number, would be three things multiplied together. So for instance, the cube root of 8 would be 2 times 2 times 2, because that equals 8. So how you do this on your calculator is you want to go to the math. Move this up a little bit. You want to go to the math button. And then we want to arrow down to number 4. Notice you have a 3 and a square, or not square root, a 3 and then a radical. That means the cube root. So we can put in 64 and we get 4. So that means 4 times 4 times 4 equals 64. Or 4 cubed equals 64. So we got what our number cubed is. So b equals 4. Again, b does not equal 4 cubed, but b equals simply 4. Okay, so now we need to put this into our kind of formula over here. So we will have x plus 4 times the quantity of x squared, because a squared, minus a times b, which is x times 4. X times 4 will just be 4x, plus b squared. B is 4. So 4 squared is 16. Okay? But now we always ask ourselves this question: is this as simplified down as I can get? So let's think, what are some factors of 16 that will add to be negative 4? So we have 1 and 16. We have 2 and 8. We obviously have 4 and 4. I think those are all of them. So is there any way that we can add, subtract any of these to be positive 16 and negative 4? So if you're kind of looking at these, trying to figure it out, you should be coming up sorry, I had to email really quick. I had to get it off the screen. I didn't know if you guys could see or not. You should be coming up with nothing, right? So from here, we would just solve for both in order to find 0. Here, you would have to apply the quad form, which is not something I want to do in this problem because I have like no room to do so. But that's what we would do in that circumstance. And that's in a later kind of part here. So that's good for that example. I'm more concerned that you know how to apply sum of cubes to these. Okay, so now let's look under this one. We need this written as a number or a term cubed, and this written as a term cubed. Right now, x is written cubed, but we also need to focus on this 27 part. So again, let's go see, is there a clean cube root of 27? Yes, in fact there is. That is 3. So we will now write this as 3x quantity cubed. So now a equals 3x. Now, what about 125? 125 is, oh, sorry, I thought you could see that. 125 is 5 cubed. So we write this like that. And now our b is going to equal 5. So again, a little bit of plug and chug. We have to do a plus b, 3x plus 5, times a squared. So 3x squared. Let's keep in mind our exponent properties. This means our 2 applies to the 3 and to the x. So this is 9x squared. Okay, so we have to write 9x squared for this. And now we're going to have a minus b, or minus a times b. So 3x times 5 minus 15x. b squared. That's 5 squared. 5 squared is 25. Okay. So at that point, this is a totally new type of factoring, something that I haven't shown you how to do yet. So until we get to that point, I'm not going to expect you to solve this to find the zeros or solutions yet. So this is where we're going to stop for now until I show you how to factor something like this. That is coming, I promise. So that's it for sum of cubes. Now, you knew it was coming. Difference of cubes. I'm only going to have you do one because as you can see, this process is super similar to the sum of cubes formula. The only difference is instead of having subtraction, we have addition, and instead of having addition, we have subtraction. Only two things, but the whole process stays the same. We need to find what our a cubed is and what our b cubed. So we need to find this cube root and this cube root. Okay? So again, go math down to cube root. We want to find cube root of 8. That's 2. What's the other number we have? 125. We already know from up above that cube root of 125 is 5. And now we just found out the cube root of 8 is 2. So we're going to have 2z quantity cubed subtracted from, oh, I wrote this a little bit too high, subtracted from 5 cubed. Very clearly, my a is 2z. It's everything in the parentheses, keeping in mind that we don't bring the cubed with us. The cube stays behind. And my b value is 5. Okay. So from this point, we just have to plug and chug. So we are taking a minus b, so 2x minus 5, and a squared, 2x squared. Again, this 2 is applying to the 2 and to the x. 2 squared is 4 times that. Oh, I'm sorry. Is that something I forgot? No, I got it. Okay. So 4x squared is going to be 2x. My a squared, sorry. And now plus a times b. A, 2x, b, 5. 2x times 5 is 10x. And added on to b squared. B squared, 5 squared, 5 squared is 25. Again, this is a form of factoring that I have not shown you yet. So you get to go ahead and leave your answer like this for right now. Okay. So that is how to factor out a monomial, or greatest common factor, and then sum of cubes and difference of cubes. So we will do the corresponding homework with this, and then move on to that last form of factoring, and I'll show you how to do this. That's that form of factoring that I still need to show you. And then we're going to take a day to kind of put all of these together in a worksheet and see where we're at with factoring. Keep in mind, these are difficult forms of factoring. So if you're a little bit frustrated with it and it's taking you a little bit longer to get the hang of it, that's okay. These are harder. And you're going to see that this last form of factoring right here that I still have to show you is the hardest of them. It doesn't mean it's impossible by any means. These are just a little bit more difficult. They might take a little bit more practice. So I will post the homework on the slides for this assignment. But if you feel you need extra work on this or extra practice, feel free to do more. I only give you the bare minimum because if you got it, you're good, you can stop. But if you ever feel like you need to do more homework than I've given you, please do. There's nothing wrong with doing extra practice, okay? So that is all. Uh-oh. Sorry, I X'd you guys out, but you're still. Oh, there we go. Okay. I hit that button where it just like makes everything disappear. Okay, sorry about that. All right. Thank you very much.